And in this video we will explore something called a link constraint, and this is an extremely useful tool that we need to use, but it's a little bit complex, and sometimes people can get a little bit lost while using it, simply if you don't follow certain rules and you don't fully understand what it is doing. But most often the problem is going to be that you are not planning. So if you're trying to freestyle it and use a link constraint, that's always going to end in a disaster. So it's really, really important to actually plan ahead and to do things in a nice order so that you know actually what's going on, that you're always in control. What does the link constraint do? Well, consider this animation. So we have this guy, our character, and he has a ball, and he's supposed to throw this ball into the air and then catch it. And at the moment the ball is not doing anything. So if we were to simply link this ball with the parenting link that we've done so far, link to the hand, it follows, but we don't really have a way of detaching it. So sometimes I see students trying to do, for example, okay, so now it's gonna start moving up, and then you start moving it up from, let's say, frame 12 or whatever. But the problem is that it's still linked to the hand, and as you can see, no matter where you move it, it's still going to inherit the orientation and the movement of the parent itself. Therefore, the solution is not to actually link or parent. What we need actually to happen is dynamically to tell to this ball, okay, from frame 0 to frame, let's say, maybe 14 or 12, you are parented to the hand bone, then you are not parented to it, you're parented to the world, and then from frame, let's say, 38, you again become parented to the hand. So we need a dynamic way of linking, and that's exactly what the link constraint gives us. It gives us the ability to dynamically link in time and change parents without changing the actual hierarchy. It's incredibly powerful and super useful and really, really unnecessary tool to actually have, but there are a couple of things that you need to keep in mind. First of all, it's really easy to get lost when working with a link constraint, and it's really easy to get work lost while working with a link constraint. If you follow a couple of simple rules that I'm going to just lay out when doing this example, you won't have a problem. But you will have a problem if you just try to do randomly without understanding, just click buttons and see what happens. It's very, very low, chances are extremely low that anything good is going to happen. So you need to plan and you need to understand what it is that you want to do. With that in mind, I'm going to start setting up this scene so that you can see a basic workflow how to actually work with an animation constraint or a link constraint. So let's say we have this scene. I know that I need to actually establish a link constraint on my on the ball itself. First thing I'm going to do is I'm going to create a point helper that I'm going to align position and rotation pivot point to this ball. So what actually I'm doing with this point helper is I am recording the position of this ball relative to the hand. And the next thing that I'm going to do is I'm going to just link this helper, and I'm just going to call it ref for reference ball. And now when I play the animation, you can see that I have this relative position of the ball so that it sits nicely in the hand, recorded with this point. And I can use it at a later date to actually simply align the actual ball to that piece of geometry. So that's good. Now the next thing that I need to do is to start establishing the link constraint. So first we know that we're going to start with the ball linked to the hand bone, this one here. So I'm gonna go to animation constraints, and there's link constraint, and I'm going to click on the hand itself. Now notice that in the link constraint you have add link, link to world, or delete link, and basically at frame 0 right now we are linked to right hand. But consider a situation that maybe you wanted this ball to be linked to the world at the beginning for whatever reason. What happens when I link to world, it seemingly disappears, but it didn't. It simply offset all the way there. What's actually happening is that when we established the link to the hand, link constraint memorized the relative offset of this ball in relation to its parent. So if you pay close attention, when I actually link it to the back to the hand, it's right where it needs to be. Let's see, where is the so in this configuration, this ball's parent is this hand, and this hand has a pivot point right over here. So let's visualize this distance between them. They are kind of, yeah, you can visualize the difference. Now notice what happens when I switch it to world. It has changed, but the relative offset is pretty much the same. So the only thing that is happening is that the link constraint takes into consideration where is this object in relation to its parent at the moment of establishing a connection. If I change that parent, the relative offset is going to stay the same, and it's going to reposition itself to the new parent. This is desired behavior, but if you don't understand what's happening, it may seem confusing. This is exactly why we have established this reference position in the first place, so that we can easily come back. Similarly, if the world was its original parent and it was positioned here, and then I decide, okay, I'm going to link it to the hand, it's going to offset, and this time it's going to go up here. And this is precisely how the difference between the world origin and the hand bone. So right now it understands this is my parent and I'm offset by that much. So now that you understand what's going on and why the offset is there, we're going to start establishing the connection how it should be happening. So I'm going to go into animate mode, and I am going to align this bone to the reference, and I'm going to make sure that we are using the right hand bone at frame 0. If I scrub the animation now, we can see that the ball is firmly planted in the hand. However, we need to release it at some point and then catch it again at some point. So let's find a suitable place when to actually release this ball. So I think, yeah, somewhere around frame 12 or 13, we can do maybe at frame 13, let's say that. So at frame 13, I want this ball to become disconnected from the hand. So all I need to do is I need to tell it, you're going to link to the world right now. That's okay. And I'm going to set a keyframe for that ball. And I'm going to do the same thing at frame 0. This is a very important step. Every time you change the parent in a link constraint, be absolutely certain that you set a keyframe on all by pressing the K button. Alright, so now our ball is going to be, you can see that it's disconnected, and we need to catch it again, and let's say that we catch it at frame 38. So now I am going to align the ball to the reference, and I'm going to add a link to this bone again. So right now what's happening is we release the ball and catch it, and that's that. So we have effectively now established the dynamic change of parents for this ball. So all that remains for us to do is to animate the ball going up into the air. So let's see, we start at frame 13 and end at 38. So 38 minus 13 would be 28, 25. So we are 25 frames. For the duration of 25 frames, this ball is going to be in the air. So the midpoint where we want the ball to reach the maximum height should be about 12 frames into the animation. So that's going to be 13 plus 12 is 25. So I'm going to go to 12, 25. Animate mode on. I'm simply going to move it vertically to a certain height. And you'll see that the ball goes up and down. Now, when I play, this is okay, but we have a bit of a dynamics issue because our curves are not optimal. What actually needs to happen is that we need to adjust our position curves, or all of the curves actually, because it's moving in 3 dimensions. And you can see that at the moment of release, it's starting to speed up and then starts to slow down. Instead, like we have learned before, what we need as a behavior is fast. So it needs to immediately leave the arm and then continue falling until it is being caught. So if I play it now, you can see that we have much better dynamics of releasing and actually catching. And one final thing that I'm going to do is, just to make it a little bit more fun, is I'm going to add the spin of the ball while it's in the air. So what I'm going to do is I'm going to go all the way to the end when it is caught, and I'm going to rotate this ball by precisely 720 degrees. I'm using angle snap here, and I'm going to release it. And now when I check this, if I just play it, it's not going to be correct. It looks okay, but not perfect. What we actually need for it to happen is we need this rotation to be linear, so that it rotates in equal speed during flight. So I'm going to hit that, and now I'm going to play. And right now, so if I turn off this edged look, you can actually see that we have successfully established dynamic changing of parenting for this ball object. It's incorporated into the animation, and it also contains its own animation itself. So that's basically how you go about using a link constraint and how to incorporate it successfully into a scene.